Well, before we actually start this next section, I want to take just a second to just impress upon you how important the ideas are that we're going to cover in this video and in the next one. So this section contains really the most important ideas that we're going to cover all year. They're very fundamental, very crucial to algebra. And if you understand these, you're really going to be in good shape. And you're going to use these in really every math class that you take until you're done taking math. Really important ideas. So I can't stress that enough. So make sure that you're putting in the work that you need to, asking questions and that sort of thing. So the I can statement for this section is I can solve one-step equations. So just one step in these, and you may have seen something like this before, but we want to make sure that we understand fundamentally what's going on here and how do we actually learn how to solve these particular type of equations. So as a warm-up, I just want to try just a quick little game. It says pick any number between -20 and 20 and write it on your paper. Now, since this is a video and we can't really interact, let's just kind of follow this through. So go ahead and pick a number, subtract 5 from it, and then tell me what the number is when I ask. So let's say, for instance, somebody said, hey, my number is -12. And I said, oh, okay, was your number then -7? Was that the original number? Or let's say somebody says the number is 6. And I say, okay, was the original number 11? And in each one of those cases, the person would have to say yes. So the question is, how does this work? Well, it's no trick here. I mean, if you subtract 5 from a number, all I did is I did the opposite of that. I just took the answer that they gave me and I said, okay, I'm going to take this and I'm going to add 5. I'm just going to kind of reverse that process. Okay, now that's going to come into play here in just a second. So let's talk about what an equation is. What is the root word of the word equation? The root word of the word equation, kind of look at the spelling there, see if you can think of what it is. It's equal. Okay, so if somebody says equation, I mean, it sounds like a scary word, but all we're talking about is an expression with an equal sign in it. So an equation is a mathematical statement that sets two expressions equal to each other. It's got to have an equal sign in there. And the equation can be true or it can be false, depending on what values we plug in or what we substitute in for the variable or the variables. Okay, so the goal of solving an equation is to get the variable, get that unknown quantity, that symbol that we use to represent an unknown number, on one side all by itself. So we can read the answer off on the other side. So the answer, or in other words, sometimes we'll use this, we'll say it's the solution. AKA stands for also known as the solution. So the answer or the solution is the number that makes the equation true. Now this is a big deal and I want you to put an extra set of asterisks on that. So the answer is the number that makes the equation true. So it's the number that we can plug in to make the equation true. We don't want a false equation, we want a true equation. We want the two sides to be equal to each other. So it's kind of like the game and the warm-up. What we want to do is we want to find what the original number was in the equation before any math was done to it. Okay, and there's a really specific way that we're going to go about doing that. We solve equations using what are called inverse operations. So let's write the word inverse there. And let's talk about what inverse operations are. So inverse, we'll go ahead and write that again. Inverse operations undo each other. It's kind of like they cancel each other out. What one did, the other one is going to undo. Now, when we use the word operation, don't forget that operations are things like adding, subtracting, multiplying, and dividing. Getting a little sloppy here. Okay? But those are the four basic operations that we've learned about: adding, subtracting, multiplying, and dividing. And each one of these is the opposite of another. So the inverse of adding is subtracting. Adding and subtracting will undo each other. The inverse of subtracting is going to be adding. The inverse of multiplying, I'm using a little dot for multiplication, and I'm using the horizontal line with the two dots for division. So the inverse, or the thing that undoes multiplying, is dividing, and the inverse of division is multiplication. And there's a reason that we learn them this way. You learned how to add, then you learn how to subtract, then you learn how to multiply, then you learn how to divide. We learn how to add first, and then we learn how to undo that. We learn how to do the opposite of that. We learn how to subtract, and we learn how to multiply, and then we learn how to undo that. We learn how to divide. So each one of those is an inverse, or it undoes does the other one. So I want you to stop and think about this question, and I think most people would know the answer to this. We just kind of intuitively, just kind of naturally know this. How do you undo adding 6? Or in other words, what would the opposite of adding 6 be? Well, it would be subtract 6. Subtract 6. How do you undo subtracting 7? Well, you would add 7. Okay? So these are some of the basic ideas that we use to solve equations using addition and subtraction. So an equation is like a balance scale. It's like the two sides of the equation are equal to each other, and we want to keep them balanced. So what that means is whatever we do to one side, we must also do to the other side. Whatever we do to one side, we've got to do to the other side. And this is sometimes called the golden rule of algebra. Whatever you do to one side, you've also got to do to the other side. Now I want you to take a look here. There are a couple things that are in bold. We've got the answer to an equation is the number that makes the equation true. Inverse operations, that's bolded, they undo each other. And when we solve an equation, we kind of think of it like a balance scale, and we need to keep those sides balanced, so whatever we do to one side, we need to do to the other. Really need to keep those in mind. And then one last thing before we go through and do a couple of problems. I want you to remember that algebra is math that's done with the use of variables. And for the rest of the unit, we're going to be learning how to solve algebraic equations. And again, if you can solve equations, you're in really good shape, not only for this year, but in any math class that you come to in the future. So it's well worth putting the time in to understand how these work. So I've got 4 problems here, and then we're going to do a couple from the assignment. But let's really think about what's going on here, and I've got some key points that I want us to take note of as we go through and do this. So here's what we want to do. We want to take a look at this, and we want to solve each equation using an inverse operation, and we want to make sure that we're showing our work. So this says y plus 6 equals negative 10. So we started out with this number y, we added 6 to it, and we ended up with negative 10. So what we're going to do is we're going to undo that adding 6. We're going to try and get that y all by itself so we can read the answer off on the other side, and we're going to do that by getting rid of this adding 6. So let's stop and think about this. How do you undo adding 6? Well, we would subtract 6. So what we're going to do is we're going to subtract 6 from this side. But remember, this is like a balance scale. So whatever we do to one side, we need to do it to the other side. It wouldn't be fair to take 6 pounds off this side if we didn't take 6 pounds off that side or something like that. So 6 minus 6, that's a 0. Sometimes we'll say that those cancel each other out. So we'd have y plus 0 equals, oh, and then we've got to combine these together. Same sign, find the sum. So that's going to be 16, and it would be negative 16. Now this right here, we're not going to do this all the time. I'm going to make a point of this a couple times, and then we'll just kind of leave it. Y plus 0. If we add 0 to something, remember that's called the additive identity, it just stays the same. So this is just going to be y equals negative 16. So what that means is y is equal to negative 16. This is the answer. Remember, the whole point of solving an equation was to get the variable on one side completely by itself so we could read the answer off on the other side. So this is y is equal to negative 16. Now let's check that and see if it actually makes the equation true. So I'm going to do this. I'm going to take this and I'm going to plug it in right there. So wherever there's a y, I'm going to put a negative 16. I'm going to add 6 to it, and I'm going to see if it equals negative 10. So let's stop and think about this. Different signs, we find the difference. The difference is 10, and the bigger one's negative. So this would be saying negative 10 is equal to negative 10. Well, that would make it a true equation. Okay, so that checks off. We've got that. All right, let's do another one. Oh, before I do that, let's take a look at this. We use the word cancel a lot when we're solving equations, and it's important to know what we mean by the word cancel. If we say we cancel something, we make it as if it never happened. So by doing this problem right here, by subtracting 6 from both sides, it's kind of like we didn't change the y at all. It's as if that adding 6 never happened because adding 0 doesn't change it at all. So these two cancel each other out to make a 0. It's as if it never happened at all. So it's important to keep that in mind. So let's take a look at this next one right here. We've got a minus 7 equals 18. So we had a, we subtracted 7 from it, and we got 18. So just like we said up above, how do we undo subtracting 7? We want to get that variable all by itself. So we want to undo the subtracting 7. Well, we're going to add 7 to this side. Again, it wouldn't be fair to add 7 on this side if we didn't add 7 over here. These two are going to cancel each other out, so I'm going to lightly cross those off like that. That leaves me with an a over here, and then I have 18 plus 7, and 18 plus 7 is 25. So that is the answer right there. A is equal to 25. Now I'm not going to do this all the time, but I am going to go ahead and plug this one in and just double check and make sure that that works. So wherever there's an a, I'm going to put a 25. 25 minus 7 is equal to 18. So that checks out. That's true. We've got the correct answer right there. That makes the equation true, so that's got to be the solution. So again, we're not going to do every problem exactly like this and show all of that work and checking and that sort of thing, but it is important that you understand how this works. And we've got to be careful. A couple things we've got to be careful with is we've got to be careful with the arithmetic. We follow the rules for integers, like same sign find the sum, same sign find the sum, different signs find the difference, that sort of thing. And what we want to remember is additive inverses cancel to be, so when we cancel these out, what they canceled to be was a 0. That's why I didn't have to write it on this one, okay? So they cancel to be a 0. Now, as we do these other problems, I'm going to show you the type of work that I want to see on every single one of them. So here's what we do. We want to get the x by itself. We want to undo that negative 14. In other words, we want to cancel subtracting 14. So the way we're going to do that is we're going to add 14. If we add 14 to that side, we're going to add 14 to this side. So these cancel to be 0. We're left with an x over here, and then we have 20 minus 14. So if we've got 20 minus 14, let's see. Oh, I apologize. So on this side we've got 20 plus 14, so that's 34. So the answer on this one is 34. Now, what I want you to take note of on this is what number is understood to be in front of the variable when it's all by itself. So when we just have a plain old x, what number is understood to be the coefficient there? Well, it's understood to be a 1. So I could write 1x equals 34, but we normally don't do that. We normally just say, okay, if we wanted it to be anything other than the 1, we'd have to put it there. So we normally don't write things like this, although you could. I want you to get used to writing it like that. So the number that's in front of the variable is understood to be a 1. So 1x is equal to 34. So x is equal to 34. Okay, let's take a look at this one right here. We've got 9 equals 10 plus v. And we want to get the variable by itself, so that means we want to get rid of this 10. Now you'll notice that there's nothing sitting in front here, so that's assumed to be a positive 10. So how are we going to undo a positive 10 or undo adding 10? Well, the way we're going to cancel that out is we are going to subtract 10. So if we subtract 10 from this side, we're going to subtract 10 from this side. These cancel to be 0, remember, so I'm going to lightly cross those off. That leaves me with a positive v, which is what I want. And then over on this side, different signs find the difference. The difference is 1, bigger one is negative, so the answer on this one is negative 1. Now you'll notice that I didn't check on either one of these. That's totally fine. As long as you go through and do the arithmetic correctly, you're going to get the answer right, but it's not a bad idea to check. Now let's take note of this right here. You'll notice that this one, first one, y equals negative 16, a equals 25, x equals 34, and this one says negative 1 equals v. Or we could read it backwards and we could say v equals negative 1. So here's the question. Does it matter which side the variable is on when we're done solving? So does it matter whether the variable is on the left or on the right? And the answer to that is no. It can go on either the left or the right. It doesn't make any difference, okay? So keep that in mind as you're solving. Now, before we do problems number 1 and 18 on the worksheet, I want to take a look at this problem right here, and I want you to think about this. What would you do first if you were solving this equation right here? There's something on there that we've talked about before, and you should know what to do. We don't like these two symbols next to each other, so I'm going to write 12 equals, this is going to be a y, and then minus a negative 2. This is implied multiplication, negative times a negative, so this is going to be a plus 2. So now we can go ahead and we can solve this. I'm going to subtract 2 from both sides. So these cancel each other out to be a 0, and over on this side I end up with 12 minus 2, so that ends up being 10. So 10 would be the answer on that one right there. Okay, let's take a look at 1 and 18, and then you'll be ready to go. So here's number 1. We want to get that variable by itself, so that means we want to undo adding 24. So we're going to subtract 24 from this side and subtract 24 from this side. These cancel to be 0, so I'm going to lightly cross those off, and I'm going to write n equals. And then on this side, I just need to figure out what the answer is. What integer is the answer? Different signs, we're going to find the difference. The difference is 14, and the bigger one is positive, so the answer is positive 14. And again, if you want to pause these and work ahead, that's fine. So there's the answer on that one. And that's the way I want you to show the work on that. Make sure you're showing all the work there, even if you can think of what the answer is in your head. Okay, let's take a look at number 18. So this says 12 equals x plus 12. So again, we want to get that variable by itself, so we're going to subtract 12 from this side. We've got to do the same thing to both sides. These will cancel each other out to be a 0, so that leaves me with x on this side just like I want. And then I've got 12 minus 12 over here. Now, sometimes people will come across problems like this and they'll think, oh my gosh, there's something wrong, because these cancel each other out. But remember what they cancel to be. They cancel to be 0. So what that means is we've got an x on this side, and on the other side we have a 0. That is the answer. 0 is just as good an answer as anything else. We didn't do anything wrong, so there's our answer on that one. So go ahead and make sure you're solving these equations, showing all your work, kind of showing how you're thinking through it, showing how things cancel, and that sort of thing. And remember, inverse operations. So good luck on the assignment.